Okay, so let's just take a look at some of the symbol conventions for the mole topic. When we're talking about Avogadro's number, we usually use Na or L. When we're talking about the number of moles, we usually use the lowercase n to represent the number of moles. When we're talking about the number of moles of a specific substance, we write n with a subscript of the specific substance. So if I have 5 moles of H2O, my N subscript H2O would equal 5 moles. When we're talking about the mass of a substance, we use lowercase m. And again, the same thing can be done where if I'm talking about the mass of H2O, then I write m subscript H2O, or in this case I wrote an H3, and then capital M is molar mass. Make sure you know the difference between these. There's a lot of uppercase and lowercase, and make sure you know where to find each of these values. A very common error that I sometimes see students making is the difference between M, MR, and AR. So again, molar mass is the mass of 1 mole of a substance. So the mass of 6 times 10 to the 23, that packet of something. When we're talking about MR or AR, we're talking about the relative masses, the relative molecular mass, the relative atomic mass. And again, this definition is a little strange, and it has to do with the history of how we found masses. And again, my HL people will have seen this last class. And so relative masses are basically the ratio between 1 mole of a substance, the mass of that, and 1/12 the mass of 1 mole of carbon-12. Now the strange thing here is if you actually calculate out each of these numbers, they'll give you the same thing. Let me show you. So if we find the molar mass of CO2, again that's adding together the atomic masses, we get 44 grams for every 1 mole of CO2, and again the units are grams per mole. If we take a look at relative molecular mass, again we're comparing the ratio of 1 mole of a substance, so 44 grams per mole, divided by 1/12 the mass of carbon-12, 1 mole of carbon-12. And again, we get 44 divided by 1, which gives us 44. But notice here that the grams per mole cancel out, and so they're unitless, again, because of their relative mass. The last thing that I wanted to just talk to you about is that there's a lot of formulas in this mole unit, and dimensional analysis is a way to avoid memorizing too many formulas. So let's pretend that you're trying to find the number of moles of something, and you have the molar mass and the mass. You know that they have to fit together somehow to find the moles, but you don't know exactly how. What you can do is you can write out the 3 possible ways that you can arrange them into either multiplying or dividing, and just calculate units. So if we're multiplying mass by molar mass, our overall units are grams squared mole -1. We know those aren't the units for moles, so we know that that's not the right formula. Here we have molar mass divided by mass, and overall we get the units of mole to the -1. Again, these are not the units for moles, so we know that this formula is incorrect. Trying the last formula gives us grams divided by grams per mole. Grams cancels out. We get 1 over mole to the -1. If you know your exponent rules, you know that gives us mole, and so you know that that's the correct formula.